If I asked you to name the most important company in the artificial intelligence revolution right now, you'd probably name some famous software developer out in Silicon Valley,
Oh,
right?
absolutely. I mean, people picture these sleek offices and, brilliant coders drinking cold brew coffee while staring at endless lines of code.
Exactly. But you would be entirely wrong, because the real bottleneck of the AI boom, the absolute ceiling on how smart these machines can actually get it, isn't code at all.
No, not even close.
It is uranium. It's like massive industrial-grade liquid cooling pipes. It's the physical global electrical grid.
Right. We have this collective psychological trap, where we look at a technological revolution and we just expect to find one magic bullet.
Yeah, we want the next Apple. We want to buy the golden ticket, look at the shiny device in our hands, and just assume we understand the whole story.
But that is a fundamental misunderstanding of how massive industrial shifts happen. I mean, it's a highly visible way of viewing the world, sure, but it tells you absolutely nothing about the underlying physical mechanisms that actually make the technology function.
And that is exactly our mission today. So welcome to another Wealthnetic Deep Dive, where our entire goal is to give you, the listener, the actual tools to spot the real economic opportunities before the masses do.
Which is so crucial right now.
Totally. We are going to decode the AI industry from first principles today. And we have an incredible framework to guide us. It's a structural map inspired by none other than NVIDIA's CEO, Jensen Huang.
Yeah, his famous 5-layer AI cake framework. We're looking at that, along with a really brilliant analytical breakdown of this entire ecosystem.
Okay, let's unpack this. Because trying to understand artificial intelligence by only looking at the smartest chatbots, well, it's kind of like trying to understand a massive commercial bakery by only staring at the frosting.
That's a great way to put it. The frosting is what gets all the attention on social media. It's what sells the product. But it is absolutely not the bakery.
No, it's not. So today, we are not talking about the frosting. We are going to look at the global supply chains of flour, the thermodynamics of the massive industrial ovens, and the sheer, mind-boggling amount of electricity running the whole operation.
We are building this AI cake from the absolute bottom up. And honestly, the physical reality of this technology is staggering once you map it out.
It really is.
It ceases to be this abstract floating cloud of algorithms and suddenly reveals itself as the most complex, interconnected, resource-heavy supply chain humanity has ever attempted to build.
And if the bottom layer of this structure fails or, even just slows down,
every single layer above it instantly collapses.
Which means we have to start our analysis at the absolute bedrock. If we want to understand where the billions of dollars of investment capital are quietly flowing, we got to look at layer one.
The foundation.
Yeah, exactly. On our framework, layer one is energy. The sources point out companies like GE Vernova, Vistra Energy, Talon Energy, Oklo Inc., Bloom Energy, and Constellation Energy. But I need to challenge this premise entirely.
Oh.
How so? Well, when I think of the AI revolution, I'm picturing advanced robotics, right? Software engineering. I am definitely not picturing a concrete cooling tower or some natural gas pipeline.
Right, it feels disconnected.
Yeah. Calling a utility provider an AI company feels like calling a gas station a race car company. Like, it's essential to drive, sure, but the gas station isn't the one inventing the engine.
What's fascinating here is that the gas station analogy actually breaks down when you look at the sheer scale of AI.
Okay, tell me why.
A gas station doesn't dictate how fast a race car can physically go. But in the world of artificial intelligence, the power grid absolutely dictates how smart a foundational model can become.
So they're the literal speed limit.
They are the strict physical bottleneck of the entire revolution. Think about what we're actually doing when we, quote-unquote, train an AI model. We are forcing tens of thousands of highly advanced microprocessors to perform trillions of mathematical calculations per second.
Continuously, right, like for months at a time.
Exactly. And when you, the end user, ask that trained model a complex question, what the industry calls inference, it requires exponentially more computing power than just a traditional Google search.
Because it isn't just diving into an index and retrieving a pre-existing web link, it's synthesizing a brand new original response on the fly.
Right, by predicting the next logical word based on billions of parameters. And every single one of those microscopic calculations requires physical electricity.
Which we don't really think about.
We don't, but the sources emphasize that these new data centers consume power on a scale that utility grids were simply never designed to handle. We're moving away from data centers that require, 10 or 20 megawatts.
And we're entering, what, the gigawatt era?
Yes. We are entering the era of gigawatt data center campuses. A single gigawatt is roughly the amount of electricity required to power a mid-sized American city like San Francisco or Jacksonville.
Wait, really?
Mhm.
A whole city?
Yeah, you cannot just plug a facility like that into a suburban power grid. The physical copper wires would melt.
Wow. Okay, that completely flips the script on what an AI company actually looks like.
Yeah.
So when we examine the companies listed in this energy layer, names like Constellation Energy, Vistra, Talon, these are heavy physical infrastructure entities.
Very heavy.
And I notice a massive theme in the sources regarding these specific companies, and that's nuclear power. Why is tech suddenly so obsessed with nuclear? I mean, why not just build a massive solar farm next to the data center and call it a day?
It comes down to a concept called baseload power. Solar and wind are intermittent, right? The sun eventually sets, the wind occasionally starts blowing. When that happens on a normal grid, natural gas peaker plants spin up to cover the gap. But an AI data center is running a single, continuous, multi-million-dollar training operation. It cannot tolerate a drop in power.
Because if the power blips, the training run crashes.
Right, it doesn't sleep. It requires constant, uninterrupted, massive baseload electricity, 24 hours a day, 365 days a year.
And nuclear is the only way to get that.
Currently, nuclear fission is the only technology we possess that provides that sheer density of carbon-free, always-on power. That is the fundamental reason why the largest tech companies in the world are suddenly signing these 20-year agreements.
To purchase the entire electrical output of recommissioned nuclear reactors, that's insane. And that explains the presence of Oklo Inc. in our framework, right? Because they aren't building those massive traditional nuclear plants that take 20 years and $20 billion to construct.
No, they're developing small modular reactors, or SMRs. The traditional power grid is severely constrained. In many parts of the developed world, if you want to build a massive new facility and connect it to the high-voltage transmission lines, you have to enter an interconnection queue.
Like a waiting list.
Exactly. And that regulatory and physical waiting list can take 5 to 7 years. In the AI arms race, waiting 5 years for electricity means your company goes bankrupt.
So the innovation in Layer 1 is entirely focused on circumventing the traditional grid.
Precisely. Oklo is designing localized, smaller nuclear reactors that can theoretically be deployed directly adjacent to a data center. You generate the massive power entirely on-site.
This sounds less like a software boom and more like a literal land and power grab.
It really is.
And speaking of on-site generation, the framework also highlights Bloom Energy. Now, they make solid oxide fuel cells. How does a fuel cell solve this 5-year waiting list problem?
It's a brilliant workaround, honestly. A solid oxide fuel cell isn't a battery. It doesn't store power. It generates it. You pipe natural gas or biogas into the unit, and instead of burning it...
Which would create massive emissions and require heavy turbines, right?
Right. Instead of that, the fuel cell uses an electrochemical reaction to strip the electrons directly from the fuel, producing electricity instantly on site.
Oh, wow.
So if you are a massive infrastructure builder, you can purchase hundreds of these fuel cells, bypass the local electrical utility entirely, and power up your data center tomorrow.
That is wild. So to summarize the absolute base of our cake here, before the single line of code is written, you need heavy industrial turbines from companies like GE Vernova to move the electricity. You need nuclear reactors from Constellation, and you need fuel cells from Bloom.
Exactly.
If you don't solve this physics problem, nothing else happens.
Nothing. Layer 1 is a strict physical prerequisite. You can have a warehouse stacked to the ceiling with the most advanced microchips ever conceived by human minds, but without the megawatts flowing from Layer 1.
They're just very expensive paperweights.
Very expensive, very shiny paperweights.
Which logically forces us upward into Layer 2 of our framework. We have the power flowing. Now we need to look at what is actually consuming it. Layer 2 is chips.
The brains of the operation.
Yeah, the sources literally describe them as the brains. And this is the highly visible layer that totally dominates the financial news. We see companies like NVIDIA, Taiwan Semiconductor, Broadcom, Micron Technology, AMD, and Intel.
It is the most famous layer, sure, but it's also widely misunderstood. Most people view this layer as a monolith.
Right. They think of a company like NVIDIA as a singular entity that mines the silicon, builds the chip, and ships it in a box.
But Layer 2 is actually an incredible, fragile, interdependent ecosystem.
So let's break that ecosystem down. First, we need to clarify why we need an entirely different type of brain for AI. For decades, the tech industry was driven by the CPU, the central processing unit. That's what Intel built its empire on.
Right.
The chip in my laptop right now is a CPU. Why can't we just use millions of those to run AI?
Because of the way they physically process mathematics. A CPU is designed for sequential processing. It does one task incredibly fast, finishes it, and then moves to the next.
Kind of like a high-end sports car. It can drive 200 miles an hour down a straight highway to deliver a single package.
That's a perfect visual.
Yeah.
But training a neural network doesn't require delivering one package at 200 miles an hour. It requires delivering tens of thousands of packages simultaneously.
Because a neural network is fundamentally a massive matrix of probabilities.
Yes. You need parallel processing. You need a GPU, a graphics processing unit. To borrow your analogy, a GPU is a massive freight train. It doesn't move at 200 miles an hour, but it has thousands of boxcars.
Meaning it can process thousands of simple calculations at the exact same moment.
Exactly. And NVIDIA realized years ago that the exact same mathematical architecture used to render millions of pixels simultaneously for video game graphics
Was the exact architecture required to train artificial intelligence. That is so cool. So NVIDIA designed the ultimate freight train. They draw the incredibly complex microscopic blueprints.
Right.
But they don't actually build them, do they? They're what the industry calls fabless.
Correct. NVIDIA is an architecture firm. They design the blueprint, but they do not own the multi-billion-dollar fabrication plants, or fabs, required to actually manufacture the physical silicon.
And that monumental task falls to Taiwan Semiconductor, or TSMC.
Right.
Okay, I'm following the manufacturing part. NVIDIA draws the blueprint. TSMC actually prints the physical silicon using those massive, mind-bending machines that fire lasers at microscopic drops of tin.
Just to carve channels the size of a few atoms. It's incredible.
Right. But looking at our framework, Broadcom is sitting right next to them in layer 2. If the chip is already designed by NVIDIA and printed by TSMC, what is Broadcom even doing? Isn't the brain finished at that point?
That is the exact trap most people fall into. They think of an AI chip as a standalone brain. But a single NVIDIA GPU, as powerful as it is, cannot train a foundational AI model by itself.
It would just take too long.
It would take centuries. To train these models, you have to connect tens of thousands of these GPUs together in a massive cluster. And they have to constantly share data back and forth while they train.
So it's not a single brain at all, it's a hive mind.
Exactly, a hive mind. But how do 10,000 chips physically talk to each other without stepping on each other's toes? That is where Broadcom comes in.
Ah, okay.
Broadcom designs the highly specialized networking chips and communication switches that allow this massive cluster to function as one unified entity. Think of it like a symphony orchestra.
Okay, I'm picturing it.
You have 10,000 virtuoso violinists. Those are the GPUs. They are all playing at blinding speed. Broadcom is the microscopic conductor. If even a single violinist plays out of sync, or if a single packet of data is dropped in the network,
the entire multi-million-dollar training run can fail. And you have to start over.
Yes. Broadcom ensures the network never drops a packet.
That makes perfect sense. So Broadcom is the nervous system connecting the individual brains. But there's another major player in layer 2, Micron technology. The sources explicitly tie them to something called high bandwidth memory. Why is memory so critical here?
It comes down to the inescapable laws of physics, specifically the speed of light and electrical resistance. These GPUs are processing data so incredibly fast that if they have to wait to retrieve data from a storage drive across the room,
or even just across the motherboard, right?
Right, the processor just sits idle. And in the world of AI, an idle processor is literally burning millions of dollars. You need the memory to be as physically close to the processor as possible.
Wait, let me visualize this. Are you saying they physically stack the memory directly onto the processor itself?
They have to. Micron manufactures memory chips that are literally stacked on top of each other, microscopic layer by microscopic layer, and then placed on the exact same silicon package as the NVIDIA processor.
That's unbelievable.
They use lasers to drill microscopic holes straight down through the stack of memory chips called through-silicon via so the data can travel vertically into the processor in fractions of a nanosecond.
That is high bandwidth memory.
Yes, it is an absolute masterpiece of material science.
It sounds like science fiction. And it proves exactly why you can't just look at NVIDIA alone. NVIDIA needs TSMC to print the silicon, Broadcom to conduct the orchestra, and Micron to defy the speed of light with stacked memory.
And of course, AMD and Intel are in this layer too, desperately trying to build their own alternative ecosystems to break NVIDIA's monopoly.
It is a brutal, high-stakes technological war. But even if you assemble all of these components, the power from layer 1, the perfectly networked memory-stacked chips from layer 2, you face another massive physical wall.
Oh, yeah, the heat.
Right, you cannot just put 100,000 of these chips on a standard server rack in a normal office building. Which brings us to the physical real estate of the AI boom, layer 3, infrastructure.
The people actually building these specialized data centers and GPU clouds.
Exactly. The sources list Oracle, CoreWeave, Nebius, IRN Ltd, Galaxy Digital, and Applied Digital. Why do we need specialized real estate? Like, what happens if I just plug all these chips into a standard Amazon Web Services data center?
If you try to run an advanced AI cluster in a traditional data center, the chips will literally melt the metal surrounding them and catch fire.
Catch fire, really?
The thermodynamics are terrifying. A standard computer server might draw a few hundred watts of power. The newest AI chips draw over 1,000 watts each. When you pack thousands of them into dense racks, the amount of heat generated is akin to a small nuclear reactor core.
So the traditional method of cooling data centers, which is essentially just pushing massive amounts of cold air conditioning through the aisles, that just doesn't work anymore.
It's no longer physically capable of absorbing that much heat. Air simply isn't dense enough to pull the heat away fast enough.
So how do they cool it? Do they dunk them in water or something?
Yeah. We have entered the era of direct-to-chip liquid cooling. Layer 3 infrastructure companies are having to design elaborate plumbing systems that pump specialized, non-conductive liquid coolants directly onto cold plates attached to the actual silicon chips.
That is a fundamental reinvention of how a data center is architected.
Completely. The building has to be designed around the weight of the water pipes, the reinforced concrete floors required to hold these incredibly heavy racks,
and the massive electrical switchgear needed to handle that nuclear power we talked about in layer 1.
Exactly. It is an entirely different asset class of real estate.
And that explains some very surprising names on this list. I mean, Oracle makes sense. They're a legacy enterprise giant aggressively pivoting their massive capital into building these hyper-dense AI data centers. But IRN Ltd and Galaxy Digital, I recognize those names.
Yeah, you probably do.
Those are Bitcoin miners. How on earth does a cryptocurrency mining company become a foundational killer of the AI infrastructure layer?
It is one of the most brilliant pivots in modern business history. To understand it, you have to look at the underlying engineering requirements. What does a massive Bitcoin mining operation fundamentally require?
Well, they search the globe for stranded, massive sources of cheap electricity, right?
Right. And they build giant warehouses with heavy-duty electrical infrastructure and massive cooling systems to run thousands of specialized computers at maximum capacity, 247.
Wait, cheap electricity, heavy electrical switchgear, massive cooling, running 247. That is the exact blueprint for an AI data center.
Exactly. Companies like Galaxy Digital realized they were sitting on the most valuable resource in the tech world. Pre-approved, highly electrified, deeply cooled physical infrastructure.
So instead of using that power to mine Bitcoin, they just swap the machines.
They simply rip out the crypto machines, install racks of NVIDIA GPUs, and rent out the computing power to AI researchers for a massive premium. They already solved the Layer 1 energy problem years ago.
That is incredibly adaptable. We also see companies like CoreWeave and Nebius in this infrastructure layer. These are referred to as neoclouds, right?
Yes, the neoclouds.
Which we are going to tear into deeply during our case studies in just a moment, because their battle against the legacy cloud providers is super fascinating. But for now, let's look at the structure we've built.
Let's do it.
We have the nuclear power and fuel cells in layer 1. We have the silicon brains, memory, and networking in layer 2. We have the liquid-cooled, heavy-duty real estate in layer 3. Everything is plugged in. Everything is turned on. Now, finally, we get to the software. Layer 4, models.
This is the layer where the actual intelligence is forged, the foundational models.
The sources list the absolute titans of industry here. Microsoft, Google, Amazon, Meta, Alibaba. And wait, NVIDIA is listed here again. How does a hardware designer end up in the software model layer?
Notice how NVIDIA crosses multiple boundaries. It's really the secret to their massive valuation. People think NVIDIA's primary competitive advantage is their physical silicon.
I mean, that's what everyone talks about.
But it isn't. Their true moat is a software layer they invented back in 2006 called CUD.
A software mode. Explain how that works.
When NVIDIA first built GPUs for video games, they realized researchers might want to use that parallel processing power for scientific calculations. But programming a GPU was incredibly difficult.
Because it wasn't made for math, it was made for graphics.
Right. You essentially had to write code that looked like a video game graphics engine just to do math. So NVIDIA spent billions developing CUD, which is basically a software platform that makes it very easy for standard programmers to talk directly to the GPU.
Wow, okay.
And for the last 15 years, every university student, every AI researcher, every startup has learned to write their AI models using CUD. It became the default language of the industry.
Ah, I see. It's like the English language. If everyone in global business speaks English, it is incredibly difficult to convince the whole world to suddenly start doing business in a brand new language tomorrow.
Exactly. So even if AMD builds a chip that is physically just as fast as NVIDIA's Mark,
The developers can't easily use it because all their existing software is written in CUDA.
precisely, it creates a massive barrier to entry. But moving to the other titans in this layer, Microsoft, Google, Meta, these are the companies building the foundational models.
Right.
A foundational model is a massive neural network, like GPT-4 or Gemini or Llama, that has ingested vast amounts of human knowledge. The reason these specific companies dominate this layer is purely economic.
Because building the cake is too expensive for anyone else.
You have to rent the infrastructure from Layer 3, buy tens of thousands of chips from Layer 2, and pay the astronomical utility bills from Layer 1. A single training run for a cutting-edge foundational model can cost over $1 billion.
$1 billion just to train it once.
Yes. Only the wealthiest megacorporations on the planet have the balance sheets to absorb that kind of capital expenditure before ever making a single dollar of profit.
So they spend $1 billion to build this incredible foundational model. But a foundational model by itself isn't a product most regular people can actually use.
No, it's really not.
It's like having a super smart brain sitting in a jar on a desk. It knows everything, it's read the entire internet, but it doesn't have a job yet. It needs to be put to work.
The foundational model is just a raw engine, but the vast majority of businesses and consumers don't want to buy an engine.
They want to buy a finished car, they want a steering wheel, a dashboard, and a specific destination.
Exactly.
Here's where it gets really interesting, because that brings us to the very top of our framework. Layer 5, applications. This is the layer that you, the listener, interact with every single day.
This is where the raw intelligence from Layer 4 is molded, restricted, and fine-tuned to perform specific, high-value tasks in the real world.
Right. This is the layer where the technology actually meets society and begins to generate diverse, sustainable revenue streams. The foundational model is general intelligence, but the application layer is specific expertise.
The sources list massive enterprise companies here. Tesla, Salesforce, Shopify, Palantir, SAP, Applevin. Let's break down how this application process actually works.
Yeah, let's do that. So if I'm a massive enterprise software company like Salesforce or SAP, do I need to spend $10 billion to build my own foundational model from scratch just to offer an AI feature to my clients?
Absolutely not. That would be a massive waste of capital. Instead, a company like Salesforce takes an existing, pre-trained foundational model from Layer 4.
Like maybe they license one from Microsoft.
Or use an open source model from Meta, exactly. Then they use a technique called fine-tuning or retrieval augmented generation to deeply educate that model exclusively on sales pipelines, customer relationship data, and enterprise security protocols.
They restrict the model from talking about anything else.
Right. So when a pharmaceutical salesperson uses Salesforce and an AI automatically analyzes their last 10 client meetings, cross-references inventory, and drafts a perfectly tailored follow-up email.
That is Layer 5 in action. The salesperson doesn't know or care about the foundational model underneath.
Exactly. Or look at Shopify. They provide the digital backbone for millions of independent online stores. They integrate AI directly into their platform to help a small business owner automatically generate search engine optimized product descriptions.
Or, digitally alter marketing images. So a t-shirt looks like it was photographed on a beach instead of a warehouse.
And the merchant clicking that button has zero knowledge of the Oracle data center or the Constellation Energy nuclear plant powering the request. Layer 5 abstracts all the unbelievable physical complexity of the lower layers into a simple, beautiful user interface.
And it expands far beyond just software, too. People view Tesla as a car manufacturing company. but their full self-driving system is purely an AI application.
Oh, absolutely.
The physical car is essentially a multi-ton robot running a deeply specialized AI model that processes live visual data from 8 cameras simultaneously to navigate a chaotic physical world.
And Palantir uses specialized AI applications for deep data integration, helping military commanders synthesize battlefield intelligence or helping hospitals predict patient intake bottlenecks.
Applevin uses highly tuned algorithms to fundamentally alter how mobile advertising and user acquisition work. The potential of Layer 5 is infinite.
It really is. Once the lower layers are established, the application layer will eventually bleed into every single sector of the global economy: healthcare diagnostics, supply chain logistics, legal discovery, material science.
Okay, we have successfully mapped out the entire 5-layer cake. From the nuclear power and turbines at the base, up through the silicon chips, into the liquid-cooled infrastructure, the massive software models, and finally the applications at the top.
The whole stack.
But mapping it is one thing. How does this ecosystem actually operate dynamically in the real world?
We're going to transition into a couple of specific case studies from our sources that prove exactly why this is not a traditional winner-takes-all tech boom.
Let's start by looking closely at Layer 3 and the story of the neoclouds. This is one of the most vital developments for anyone trying to spot emerging trends. The sources explicitly highlight a massive shift toward these neoclouds, pointing out companies like Nebius and CoreWeave as highly strategic players. I have to stop you there because this defies basic business logic to me. Amazon Web Services, Microsoft Azure, Google Cloud, these legacy cloud providers essentially print money.
They do.
They have virtually infinite capital and established relationships with every major corporation on Earth. How does a startup neocloud like Nebius even get a foothold building data centers? Why wouldn't an AI researcher just go to AWS to train their model?
It is the classic innovator's dilemma, combined with extreme technical debt.
Okay, unpack that for me.
The legacy cloud providers built their incredible empires over the last 15 years by catering to millions of different customers doing millions of different, relatively small tasks.
Like hosting a website or running a corporate email server.
Storing database backups, yeah. Their physical infrastructure was architected using standard Ethernet networking to divide resources into tiny, isolated virtual machines.
Right, they're built to be everything to everyone.
But an AI training run isn't a million small tasks. It is one gargantuan task that requires 10,000 GPUs to act as a single unified organism.
And standard Ethernet can't handle that.
If you try to run that across a legacy cloud architecture using standard Ethernet, the network latency, the slight delay in data transfer, destroys the efficiency. Furthermore, the legacy clouds are overwhelmed with demand.
Oh, so there's a supply issue too.
A massive one. If a well-funded AI startup goes to AWS today and asks for a cluster of 20,000 top-tier NVIDIA chips, AWS might put them on a waiting list for 6 to 9 months.
And in the AI industry, waiting 9 months to train your model means your competitors have already released a superior product and your company is dead.
Exactly. Enter the neocloud.
So how are they physically different?
A neocloud is a pure-play AI infrastructure provider. They do not host websites. They do not run email servers. They build data centers completely from scratch, specifically designed for one singular purpose: running massive, unshared clusters of GPUs at maximum velocity.
Wow, so they don't use standard Ethernet.
No, they use deeply specialized networking fabrics like InfiniBand. They offer bare metal access, meaning the researcher has direct, unfiltered access to the physical hardware without any virtualized software slowing them down.
So it's the difference between trying to rent a lane on a congested public highway versus building a private high-speed rail line.
That's a great analogy.
The legacy clouds have all the capital, but their existing physical architecture is actually a burden when it comes to raw AI performance. The neoclouds identified the bottleneck in Layer 3 and purpose-built a solution.
And it proves that innovation and extreme value creation are not just happening at the algorithm level.
Yep.
The brutal, complex physical engineering required to network thousands of supercomputers together without them overheating or dropping data packets, that is a massive, highly lucrative business opportunity in itself.
Which perfectly transitions to our second case study. And this one really drives home the core thesis of our entire deep dive today: the flow of capital ecosystem. The sources explicitly warn us against simplistic thinking, stating, don't think that the AI sector will have only one winning company.
If we connect this to the bigger picture, you can literally watch how a single dollar moves through this entire structural framework. In this ecosystem, capital behaves exactly like water.
Meaning it flows downwards.
Yes, it enters at the top, and gravity pulls it relentlessly downward through every single layer, nourishing the entire supply chain.
Let's trace that dollar. Let's make it concrete. Imagine an independent small business owner in Berlin. They sign up for a premium AI marketing tool on Shopify to run their online store. They pay Shopify $50 a month.
Okay, let's track it.
That money enters our framework at the absolute top. Layer 5, the application layer.
Correct. Shopify has secured the revenue by providing immediate, tangible value to the consumer. But Shopify did not build the underlying neural network from scratch.
Right. They are utilizing an API connection to a foundational model built by, say, Microsoft or Google.
So to keep that feature running, Shopify has to pass a portion of that $50 downward to layer 4, paying the tech titan for the API call to the model.
Okay, so the capital has moved down to layer 4. Microsoft has a piece of that $50. But Microsoft's model doesn't just exist in the ether. It requires massive physical computing power every single time it processes a request.
So Microsoft has to pay for the physical server space and the GPU access. Perhaps they utilize their own customized data centers, or as we just discussed, maybe their internal capacity is maxed out.
So they overflow their workloads into a highly efficient neocloud like CoreWeave or highly specialized infrastructure built by Oracle.
Exactly. And so a portion of that capital drops down to layer 3.
But Oracle and CoreWeave are just providing the real estate and the networking. They had to physically purchase the hardware inside the building.
Right. To build that data center, Oracle took massive amounts of capital and passed it down to layer 2. They bought the physical GPUs from NVIDIA.
They bought the microscopic memory stacks from Micron.
They bought the InfiniBand networking switches from Broadcom. The money cascades down into the hardware layer.
And finally, those NVIDIA chips sitting inside the Oracle data center, processing the API call from the Shopify application, they're pulling a massive, constant stream of electrical current just to keep from shutting off.
Which means Oracle is continuously writing massive checks to energy providers like Constellation Energy or Vistra just to keep the liquid cooling pumps running and the processors firing.
Wow.
The capital ultimately settles in layer 1, the physical bedrock of the economy.
That is absolutely mind-blowing. The $50 spent by a guy selling coffee mugs online in Germany eventually trickles all the way down the supply chain to literally pay a nuclear power plant operator in Pennsylvania.
That is the definition of an ecosystem. And it illustrates beautifully why looking for one single winner is a fool's errand. Every single layer of the chain captures a margin of the value.
It is a deeply symbiotic relationship. The layers reinforce each other. If Shopify builds a better interface and acquires more users, it generates more API calls, which requires more chips.
Which means Constellation Energy ultimately sells more megawatts.
Conversely, if NVIDIA designs a chip that is twice as fast, it drastically lowers the cost of compute, which allows Shopify to offer an even more powerful tool to that small business owner.
The innovation flows up and the capital flows down.
So what does this all mean? How can you, the listener, use this massive 5-layer cake framework to build your own knowledge, advance your career, or structure your wealth? We always bring our analysis back to actionable, concrete advice here on the Wealthnetic Deep Dives.
We have 3 major takeaways for you today based on everything we've unpacked.
Takeaway number 1, stop chasing the shiny object.
Human psychology naturally draws us to what we can immediately see and interact with. We are biologically programmed to focus on layer 5.
The applications, the chatbots, the software.
Right. But historically, during any massive infrastructure build-out, whether it was the railroads, the telegraph, or the early internet, the most reliable long-term returns did not come from the volatile consumer applications.
They came from the companies selling the picks and shovels.
Yes. If you want to understand where the technology industry is going tomorrow, you have to look at the foundational layers being built today. That is where the quiet, multi-billion-dollar construction is happening.
While everyone is arguing on social media about which chatbot has a better personality, the smart money is sitting in boardrooms, trying to figure out the thermodynamics of liquid cooling a mega data center in Texas.
Or how to secure enough enriched uranium to power a small modular reactor. Look at the flour and the ovens. Stop obsessing over the frosting.
I love that. The foundational layers offer much clearer visibility into future demand. A specific software application might be wildly popular today and entirely obsolete in 6 months due to a change in consumer taste.
But the physical demand for data center electricity, specialized real estate, and high bandwidth memory is locked in for the next decade, regardless of which software company ultimately wins the chatbot war.
Which leads right into takeaway number 2. Track the money flow. We just did an exercise mapping how a $50 subscription trickles all the way down to a nuclear plant. You can and should do this exercise yourself in your daily life.
It is a phenomenal analytical tool for developing business acumen. Take 10 minutes a day to map out the technological tools you use at work or at home.
Like if your corporation just announced they were buying a massive enterprise software package from SAP, ask yourself the deeper questions.
What infrastructure cloud does that software run on? What specific silicon chips power that cloud? Who manufactures the memory for those chips? Who generates the baseload electricity for that specific geographic region?
Trace it all the way down to the bedrock. It trains your brain to see the hidden supply chains that govern the modern economy. You stop seeing standalone magical products and you start seeing interconnected physical networks.
It's incredibly eye-opening once you start doing it.
And that brings us to our final takeaway. Takeaway number 3. Embrace the ecosystem mindset.
This is a crucial philosophical shift. Whether you are managing an investment portfolio, starting a new business, or just investing your time to learn a new skill to future-proof your career, do not look for the single monopoly.
Right. The market is too vast, and the physical constraints are too complex for one company to do everything.
Broaden your perspective. When you read the morning financial news, stop skimming for mentions of famous tech CEOs. Start actively looking for developments regarding the neoclouds, the utility operators,
The copper mining companies, the fluid dynamics engineers designing the cooling systems, the AI ecosystem desperately needs all of them to function.
When you understand the structural framework, it acts as an armor against hype. When a flashy new Layer 5 application gets announced and the media goes into a frenzy,
You will calmly realize that the real guaranteed benefactors of that announcement might actually be the Layer 2 networking designers and the Layer 1 utility providers who have to carry the load.
it's like unlocking X-ray vision for the global economy.
Okay, let's do a quick structural recap to lock this entire deep dive into your memory. We started at the absolute physical bottom with Layer 1, energy.
The hidden bottleneck of massive multi-gigawatt data centers, nuclear baseloads, and solid oxide fuel cells.
We moved up to Layer 2, chips, the hardware ecosystem where NVIDIA designs the architecture, TSMC prints the microscopic silicon, Broadcom conducts the networking orchestra, and Micron stacks the memory.
And then we explored Layer 3, infrastructure, the heavy real estate, the liquid cooling thermodynamics, and the agile neoclouds bypassing legacy technical debt.
That physical foundation supports Layer 4, models, the incredibly expensive software brains trained by the mega-cap tech titans using the CUDA mode.
And finally, sitting at the very top is Layer 5, applications. The consumer-facing companies fine-tuning those models to deliver specific real-world value to your daily life.
It's a triumph of human engineering, a massive interdependent ecosystem where every single tier fundamentally relies on the structural integrity of the one below it.
It permanently changes how you view the horizon of technological progress.
It really does.
Yeah.
If this deep dive gave you an aha moment today, if we helped you see the economic matrix just a little bit clearer, please make sure to subscribe to the Wealthnetic channel. Share this audio with a friend or a colleague who is curious about the future. Maybe someone who is trapped only looking at the frosting right now.
And definitely take the time to explore Jensen Huang's original frameworks and speeches online. They are an absolute goldmine of structural insight.
Absolutely.
But as we step back and look at this entire monumental structure we've built today, this raises an important question. If energy is the absolute, inescapable, physical foundation of this entire AI framework, what happens to the global economy when the exponential, ravenous growth of artificial intelligence permanently outpaces our ability to build the power grid?